Hello guys, welcome back to the channel. And today's leet-code problem is pseudo-palindromic paths in a binary tree. Okay, and the companies that have asked this problem is Amazon has asked this problem. Okay, and coming we will let us quickly dive into the problem statement here. Okay, you are given a binary tree here. You are given a binary tree. Okay, where node values are digits from 1 to 9. Okay, the digits are from 1 to 9. Okay, a path in the binary tree is said to be pseudo-palindromic. Okay, pseudo-palindromic is nothing but, I will discuss it later. And if at least one permutation of that node values in the path is a palindromic, return the number of pseudo-palindromic paths going from the root node to the leaf nodes. Okay, from the root node to the leaf nodes, how many pseudo paths are there? Okay, how many pseudo-palindromic paths are there? We have to find here. Okay, and so what is a pseudo-palindromic path? Okay, so a pseudo-palindromic path is nothing but, if this is the path 211, and if we interchange that values and form a palindromic string, palindromic one, then it is called as a pseudo-palindromic path. Okay, so it is nothing but, uh, if we if we if we try to find this path like 211. Okay, 211, this can be turned out to be 121, right? So this can be rearranged, the numbers of this path can be rearranged to these numbers, right? And if you see that, this is a palindrome, right? So in this way we need to, this is a pseudo palindromic number, right? So in this way, whenever there is a path, if we convert that path into a palindrome, then it is called as a pseudo palindromic path. Okay, so this is what a pseudo-palindromic path is. Like, so we have to find the number of pseudo-palindromic paths from root node to leaf nodes. So what is a leaf node? Okay, here what is a leaf node? So a leaf node is a node where its left and right nodes are equal to null. Okay, so let us check whether there are leaf nodes for this or not. So for this left node is 3, right node is 1, and for this left node is 3, right node is 1. For this left node is null and right node is null. So this is a leaf node here, and this is also a leaf node, and this is also a leaf node. So from here to here, how many paths are there? How many pseudo paths are there? From here to here, how many pseudo palindromic paths are there? From here to here, how many pseudo palindromic paths are there? You have to find it here. Okay, so I'll be solving this problem using DFS algorithm. Okay, so let us visualize how we can solve this problem using DFS algorithm. Okay, so for that, so as we said that, so I'll be using some backtracking also here. So for uh, for solving this problem. Okay, and yeah, as this given here, this is the main condition here, as the digits will only be in the range of 1 to 9 only, right? So 1 to 9, this is the main hint here given. So with this hint, how we can try to solve this problem? So how we can try to solve this problem, we will see. Okay, so I'll be discussing the problem here now. So let us come to the whiteboard here. So now from here, this is a node, right? So from here I can go to left or I can go to right, right? So I will check. Uh, I'll check whether from two I can, if two is left, if two is a leaf node or not. Okay, I'll check whether two is a leaf node or not. If it is a leaf node, then I need to visualize the path, right? So whatever the path up to that, I need to find whether it is a pseudo palindromic path or not. Okay, so we will check how to find that pseudo palindromic path. Okay, so from here I can go to the left, right? So I will go to left. Okay, and from here I can go to left, right? So I'll go to left here. Okay, so from here I can go to left. So but you can see that there is no left node. So we have to keep a condition that if left is equal to null and if right is equal to null, if node dot right, left and node dot right is equal to null, then it is a leaf node, right? Then we need to check the resultant path, whatever the path is there. Then we need to check that path up to that we need to check that path. Okay, so for that, what we'll do is, so like further to what to do is, so first let us check how we can find a pseudo palindromic path. Okay, so for finding a pseudo palindromic path, So let us see. See, for being a palindromic, okay, for a number, for a string being a palindromic, so we need to check here. So let us consider this part 211. Okay, so 211, and the frequency of the count is frequency of the number count is here 2, and the 2 is 1. Okay, so a pseudo palindromic path should to be a palindromic, the number of odd frequencies should be not greater than equal to 1. Okay. I repeat. So for being a pseudo palindromic path to be a palindrome, the number of odd frequencies, okay, should not be greater than 1 here. Okay. So the frequencies should not be uh, if the frequency is an odd, then the number of count of odd frequencies should not be greater than 1 here. So let us count how many odd frequencies are there here. So uh, if we see here, uh, the odd frequency, so this is an even frequency, so we should not count this. So this is an odd frequency, one is an odd frequency, right? So the odd frequency count will be 1 here. So number of odd frequencies are 1 here, so it is not greater than 1. So from these, so with these values we can form a palindrome. Okay, let us check another example. Like let us consider 231 here. Okay, for 231, how many are there? Let us find out the frequencies. Okay, and the third frequency will be 1. So how many odd frequencies are there here? So one is an odd frequency, so count will be 1, and 2 is an odd frequency, so 2's frequency is also an odd frequency, so 2 is 2. So here the odd frequency count is greater than 2, so we cannot form a palindrome here, right? So see, observe carefully here, we cannot form a palindrome, right? With 231 we cannot form a palindrome, right? So so the number of odd frequencies should be lesser than or equal to 1, then only we can form a palindrome here. So let us consider another example here. So uh, for example what we'll take is, let us take 2131. Okay, let us take 2131 as this is a valid path, right? So from root to a leaf node, this is a valid path, right? So let us consider 2131 here. So the 2's frequency is 1, and the 1's frequency is 2, and the 3's frequency is 1. So here also there are two odd frequencies, so we cannot form a palindrome with this path, right? So in this way we need to check whether we can form a palindrome or not. So if we form a palindrome, then it is a pseudo palindromic path, then we can count, so we can increase our count, right? In so in this way we need to find here. Okay. For that, what I will do is, for if we like whenever we go to the path here, whenever we go to the leaf node here, so after going to the leaf node we are going to check, right? So we are going to check. Until then we need to keep the track of this, right? So after keeping track of this, so let us visualize this problem. So okay, and so up to here there will be empty, right? Empty, like there will be empty string only. So let us consider the path is a string here. Okay, the empty string only will be there. Okay, and up to here there will be a string. So there will be a string of, so one second. So up to here there will be a string of 2, right? The path is up to here the path is 2 only, right? So now uh, up to here what will be the path? It will be 2 and 3, right? So it will be 2 and 3, and whenever I go to left, the path will be 2 3 3. So now it is a leaf node, right? This is a leaf node, and I need to check whether this path is a valid palindrome or not, right? So for checking that, we need to check the number of odd frequencies here. So the number of odd frequencies will be one only, right? So it is a palindromic path. So this function will return what it will return. So it will return, so this will return what it will return. So this will return one here, right? So here it will return one here. Okay, the count of pseudo palindromic paths are equal to one. So it will come here, and it will also check for. So now what we need to do here, we need to remove this thing. So we need to remove this thing, remove this value from our path, from our current path, so that we can go to this is what the backtracking is here. So this is what the backtracking is. So we need to remove this thing from the whatever the resultant path. We need to remove this, and we need to go back, right? Before returning, we need to go back. So we will remove this path, and we will return there. Okay, we'll return one here. So now from here it can go to right? So it will go to right, and here the path will be how much? The path will be 2 3 1, right? So here the path will be 2 3 1. So now it is also a leaf node. So we need to check, whenever there is a leaf node, then we need to check whether it can form a pseudo palindromic path or not. So for that, we need to check the number of odd frequencies here. So the number of odd frequencies here are three, right? The number of odd frequencies here are three. So two's frequency is also one, which is an odd number, and three's frequency is also one, which is an odd number. One's frequency is also one, it is an odd number, right? So there are three frequencies, so it is greater than one. So it does not form a pseudo palindromic path. From here, what we need to return? From here, what we need to return? We need to return 0 here. We need to return 0. So after returning 0, we need to remove this from our path, right? We need to remove this path, and we need to return it. So we will come here. So from here, whenever we from here, how many paths I can form? I can form 0 plus 1. So I'll return 1. Before returning, I will remove this 3 here, 3 from my resultant path. Okay, so I'll remove this resultant, I will remove this 3, and I will return that 1. Okay, so number of paths I form from here. Okay, so I will check. So from here, and I will again go to, after going to left, I will go to right here. So I'll go to right. So here the path will be how much? The path will be 2 and 1, right? So 2 and 1 the path will be. So from here, where can I go? I can go to left. So but left is null, so it will return 0 here. From the, if it is null, then automatically it is 0, right? Though no paths are formed here, right? So it will go here. So now it will check whether it is a leaf node or not. It is a leaf node. So what will be the path here? And what will be the path? 2 1 1, right? So the path will be 2 1 1. Now we need to check whether it is a pseudo palindrome or not. So we need to check. So we have to check, how to check whether it is a pseudo palindrome or not. We need to count the number of odd frequencies here. So the number of odd frequencies here are only one. So two's frequency is one, which is an odd frequency. So we need to count. We need to add it to our odd frequencies count. So one's frequency is two. Here is two. It is even. So we need to we don't need to add it, right? So here our only the count of odd frequency is 1. So which is lesser than or equal to 1, right? If it is lesser than or equal to 1, then it is a pseudo palindrome, right? So from here, what we can return is, we can return 1 here. From here, we can return 1, right? Before returning, we need to remove this uh, last element from that resultant path. Okay, and we need to return it. So from here, what we will return? We will return left plus right? So left is 0 and right is 1. So what will return? 1 here. right? And we need to remove this last element from here. So what are the number of ways we can form here? So the number of ways is left plus right edge, it is 2. So the number of pseudo palindromic paths that can be formed is 2 here. So is it this is the answer? Yes, this is the answer, right? So in this way we need to try to solve this problem. So we will try to solve this problem in this way. But if we solve this problem in this way, it will give us memory time limited, the memory time exceeded. Okay, memory limit exceeded. Why? Because for everything we are storing its path, right? For every time we are storing its path, right? For every time we are storing its path. It takes uh, for every iteration we are storing its path. So for every iteration we are storing its path, that memory consumption is more here, right? So we need to decrease the memory consumption here. So how to decrease the memory consumption? So as I said before, what is the hint given to us? It is given as there are only 1 to 9 digits, right? So there are given only 1 to 9 digits. So initially we make an array count of 1 to 9, and whenever we are going, we will increase that count and check and pass that array as an parameter and check whether there are how many. Whenever there is a leaf node, we will pass that array as a parameter instead of that whole path. We will pass this array as a parameter and check whether it can form a pseudo palindrome. What this array stores? The frequency of this thing, the frequency of elements here. So 1 to 9 are elements. At max there can be only 1 to 9 elements in that path, right? So initially if we try to store an array in this way, and if we try to store its frequencies, and if it if a leaf node comes, then we can pass this array as a parameter, and can it can be checked directly, right? So here we can check how many odd frequencies are there from here. If it is greater than 1, then we need to return 0. If it is lesser than or equal to 1, then we can return 1. So when we are returning, we can decrease the frequency count, right? It is simple. It is better deleting the path, deleting an element from a path, or it is decreasing the count from a path. So decreasing the count, right? So here this is an optimization here. So memory optimization is required here. Okay. So uh, so so how we will be solving this problem? So initially we are at 2. So our 2 count will be 1. Okay, so now we will go to 3. So now our 3 count will be 1. Okay, and we will go to left here. From 3 we will go to left, and 3 count will become 2, right? It is a leaf node, and we will pass this as an parameter for for checking whether it is a pseudo palindrome or not. Now from here it can see, right, there are only one odd frequency, so it will return it is a true. It can form pseudo palindromic. So before returning we need to decrease the count frequency, so element frequency, and we need to return the 1 here. Okay, we will return 1. So from up to here we need up to here, how many numbers we have? Only 2 and 3, which are 2 and 3 only, right? So after going to left, after we need to go to right here. So before after going left, after going right, we need to add this to our frequency count, right? So we will be adding. So it is a leaf node, and we will be passing this array as a parameter. Now it will check how many odd numbers are there. So 1 1 1. So there are 3 odd numbers which is greater than 1. So we need to return 0 here. Okay, so before returning 0, we need to remove this from the count. We need to subtract 1 from our count frequency, right? So we'll be subtracting 1 from our count frequency. Then we need to return the left plus right, right? Left plus right will be returning. So before returning, we need to decrease the count of 3 element here. Okay, we will be decreasing the count of 3 element, and we will be returning 1 here. Okay, so after going left, we need to go right, right? So we go right and increase the count of 1 here. Okay, it will be 1 1, and there is no left, right? So we will go right here. We will go right and increase the count of 1 here. So this is the leaf node. We will pass this as a parameter. So it will check how many odd frequencies are there, only one. So this is a valid, this can form a pseudo palindromic path. So it will return one. Before returning one, what we need to do, we need to decrease the frequency of one variable here. So here what it will return, left plus right. Left is 0 and right is 1, so it will return 1 here. So before returning one, we need to decrease the element frequency. We will decrease the element frequency and we will go here. So here what we'll do, we will return left plus right. So before returning left plus right, what we need to do, we need to decrease the element frequency. So this is how we will be solving this problem using an frequency array here. Okay, now let us quickly go to the code and see how we can solve this problem. Okay, so uh, I have taken a frequency array here. So array 10. So 1 to 10 there are 1 to 9 there are numbers, right? So the array frequency is 7. Array frequency is this thing. So I have passed this array frequency in a DFS algorithm, which is a pre-order traversal. Okay. So I'll check whether my root is equal to null or not. So if it is null, then I need to return 0. Here what I did, when the root is null, right, I have written 0 only, right? So I need to return 0 there. So after returning 0, what we need to do, we need to increase our element frequency, right? So we need to increase our element frequency and we need to check whether it is a leaf node or not. Okay, if it is a leaf node, what we need to do, we need to get the count, get the count of how many odd frequencies are there. Okay, see, so this is how we form, we will try to get how many odd frequencies are there in are there in the array frequency or not. Okay, so if it is greater than or equal to 1, so after getting it, we need to, before returning, we need to decrease the frequency, right? We decreased the frequency, right? And we need to check whether if it is lesser than or equal to 1, then we need to return 1. If it is greater than 1, then we need to return 0 here. So we return 0. So and we need to go left and go right. We'll go left and we'll go right. And after going left and right, we need to decrease the frequency of the value, and we need to return, right? Before returning, we need to decrease, right? That is what backtracking, right? So we are using here. So this is how we will be solving this problem here. So what are the concepts we have used here? Backtracking and DFS algorithm, right? DFS algorithm, pre-order traversal, and backtracking here. So with this help of with this help with these three algorithms, we are able to solve this problem. So we'll let us try to run this problem. So it is accepted. Let us submit it. So it is submitted successfully. So coming to the time complexity of this problem, what will be the time complexity now? So it will be at max the depth of the tree, right? So in a DFS algorithm, what will be the time complexity? It will be the height of the tree, right? What is the height of the tree? It will, the time complexity will be the height of the tree. And what will be the space complexity here? As we are using only array space, which is 10, right? Only 10. So for this, the space complexity will be, for every iteration, it will be, so for every iteration into 10, right? So how many iterations it can take maximum? So it can take up to 10 to the power of 5, right? So 10 to the power of 5 is the limit. So the number of nodes that can be uh, there in a tree is 3 are 10 to the power of 5. So 10 to the power of 5 into 10 to the power of 10. So 10 to the power of 6. 10 to the power of 6 will be the space complexity. Here, the time complexity is, so for every leaf node, uh, there is a check, right? There is a big often, there is a 10 check. There is a 10 check, right? Into 10 check, right? So for depth of 3 into the time complexity will also be depth of 3 into 10, right? So let me write this. The time complexity will be, sorry, height of 3 plus into 10. Okay, this will be the uh, sti- time complexity, and space complexity will be uh, number of valid nodes. The number of nodes are 10 to the power of 5, right? So 10 to the power of 5 into, so big of n only, right? Maximum it can be big of n only, right? So n is the number of nodes here. Okay, so n is the number of nodes here, right? So into 10, big of n into 10. So the space complexity will be this thing, and height of the tree into 10. That will be the time complexity. So this is what the time complexity and space complexity of this problem, and this can be solved using backtracking and DFS algorithm, and it can be also solved using BFS algorithm also. So so this is how we'll be solving this problem. And thanks for watching this video, and please subscribe to the channel, and thank you.